Hello. In this chapter again, our whole goal is to find where two lines cross. If you missed the first lesson, maybe go back and watch the first video for this chapter. We're going to do a warm-up question that assumes you know a little bit about what we did prior. So this is kind of a review question of the first lesson to maybe get those caught up that missed it. So on the back of the whiteboards, this is a question for your whiteboard. It's not in the note packet. I'd like you to find the solution to the linear system by graphing and then check that that intersection point is actually a solution to both equations. So first solve for y, then graph the lines. So solve for y and then graph both lines, find where they cross, and make sure that the intersection makes two true statements. So pause the video now for maybe a minute and a half, give people a chance to try. If you were gone, maybe work with someone who was here so they can help you. And then after a minute and a half, unpause the video so I can talk our way through it. So pause video now, please. Okay, first thing you need to do is solve for y. When you solve for y, you then get y equals x plus 6 and y equals negative 2x. It's really negative 2x plus 0, so that would be where the y-intercept is. And then you graph each line. So this first one right here is shown in red. This second one is shown in the purple. And then you find where they cross, and they cross at negative 2, 4. That would be the answer. If you put negative 2 in for x and 4 in for y, you'll end up getting two true statements. So the solution, you would write it as the point, negative 2, 4. When you write your solutions in this chapter, you have to write both the x and the y coordinate because it's a point where they cross. That is what we were working on in the first part of the chapter. Now, if you would, your note packet should start with a topic that says something about solving linear equations by substitution. Might be the first of the few days that we look at this. And the first example is we're going to try to solve by graphing, right? So the whole goal of the chapter is to find where two lines cross, so we're going to do it by graphing. So let's try it. So if I were going to do that, I would first solve for y. So in the first one, how do I get y solved for? I subtract the 1x from each side. I then get 2y equals 6 minus 1x. If I divide everything by 2, I then get the line y equals 3 minus 1/2 x. So if I were going to graph this, I would start at 3 and then go down 1, right 2, down 1, right 2, down 1, right 2. I'll leave you to kind of draw the line in on your own. Second one, if I solve for y by subtracting the 3x, I get negative 2y equals 5 minus 3x. Then I divide by a negative 2, and I'll be left with y equals negative 2.5. Negative divided by a negative makes a positive 3 halves x. So this line would start at negative 2.5. and go up 1, 2, 3 and right 2, up 1, 2, 3 and right 2, and then you draw the rest of the line in. I'd like you to finish graphing it and tell me where those two lines cross. So maybe take a few seconds and do it. As you start to do it, you might notice something. Like if I ask it to graph these two lines, there's the first one. The second one's right. Come on. Should be, there we go, right there. You'll notice we got an issue here, right? If I ask you where those two lines cross the issue, what do we do if two lines don't cross at a nice intersection? Like we're going to have to estimate with decimals. So what else can we do if we can't say exactly what the intersection point is? Well, we need a new tool. Graphing is only good if my lines are going to cross at whole integer values like 2.0 and 4.0 or something like that. So as long as I have integer values, but otherwise graphing's not great. So we need a new tool. To introduce this tool, and I hope you appreciate what the issue is with graphing now, we'll start with a fairly simple riddle, because when you see riddles like this, they're actually using the mathematical property that we're going to need. So here's the riddle. It says George and Sally are giraffes. Hint 1 is that their combined height is 19.5 feet. So I'm going to write an equation for hint 1. Their combined height is 19.5 feet. So that means if I took George's height plus Sally's height, it would be 19.5. That's what we mean by combined. The second hint is that George is twice as tall as Sally. George is 2 times as tall as Sally. So George is equal to 2s. Now, how can I use this information to figure out how tall each of them are? Well, let's think about this. I need to like use the clues. So the first equation says that George plus Sally is 19.5, but then the second equation gives me an extra hint about George. George is equal to 2 Sallys. So I can use this piece of information to rewrite what do I know about George in the first hint. Instead of writing G right here, I can use the fact that I know that G in this first equation, so I'm going to rewrite this first equation, G is actually 2 S's. So 2 Sallys plus Sally equals 19.5. Well, 2 Sallys plus another Sally is 3 Sallys equals 19.5. And then if I divide by 3, I'll find that Sally's height is 6.5 feet. Once I know Sally's height, I can figure out George's. Because if I go back here, I can use either hint, equation 1 or equation 2. I think equation 2 is probably the easiest. George is equal to 2 Sally, so George is equal to 2 times 6.5, which means George has to be 13 feet tall. And now let's check that it solves our riddle and makes both clues true. Their combined height is 19.5. Yep, if I add them together, I get 19.5. George is twice as tall as Sally. Yep, if I take Sally's 6.5 and double it, I get George's height is 13. This little clue, or this little riddle that we solve with 2 clues, the process is actually mathematical, and the process has a name. The technique is called solve using substitution. It's called substitution because I use this second clue to rewrite the first clue using the second clue's information and a substitution step, because instead of writing G, I substituted in the fact that I know that G was equal to 2 S's. So this process for doing this is shown below. Step 1 is solve one of the equations for one of the variables. In our giraffe example, that was this second equation. G was solve for. When we say solve for, we mean get a variable by itself. G is equal to 2 S's. Second step is substitute that variable into the other equation and solve. That's what we did here. That was this black line I drew. Take that second clue and use it in the first equation. Sometimes it goes the other way. Sometimes I'm using the first equation to rewrite the second. Step 3 is substitute the value you got in step 2 into either of the original equations and solve for the last variable. That was shown right here. Once I figured out how tall Sally was, 6.5, I could put 6.5 in for the red S or the blue S and figure out how tall George was. There's the steps. If we need to pause the video so that everyone can write down the steps in their note packet, feel free to do so. Otherwise, I'm going to assume that we're good and we'll do a few more examples. So here we go. Step 1 is solve for one of the variables in one of the equations. Well, that's actually already done for us. Step 1 is done because y is already solved for. Now I'm going to take what I know that y is equal to. Y is equal to 2x minus 6. I'm going to use that to rewrite the second equation. In this second equation, when I get to y, I'm not going to write y. I'm going to write the fact that I know that y is equal to 2x minus 6. That will allow me to solve for x, because then I only have one type of variable to worry about, x. So when I rewrite the second equation, 4x plus 6, this is the substitution step. So step 1 was already done for us. This is step 2, substituting. I would write, instead of writing y here, I write 2x minus 6. I need to put parentheses because there was a 6 out in front, and everything in there has to get multiplied by 6. Now, we're going to solve using our steps of simplify, same side solve from earlier in the semester. That's why we practice it so much. Simplify usually means to distribute first. The 4x is just hanging out, waiting for the 6 to distribute. I get 4x plus 12x minus 6 times 6 is 36 equals 4. Now I've got variable, variable, number, number. I can put my variables together and make 16x's minus 36. Now I'm done with simplify. I need to get same side by adding 36 to each side. I then get 16x equals 40. And if I divide by 16, I then get that x is equal to 2.5. And this is an excellent example because my point of intersection has a decimal. That's why graphing wouldn't have been a great, fantastic choice. So I'm done with step 2. Now I'm on to step 3. I need to use the fact that I have one of the coordinates to get the other coordinate by substituting the value I got in step 2 into either of the original equations. So I'm going to put 2.5 in for either this top x or the bottom x and solve for y. One of them is much easier than the other, and that's the top one because y is already solved for. So I'm going to put 2.5 in for x in the top equation. When I do that, I'm going to get the equation y equals 2x minus 6, but instead of writing x now, I'm going to write the fact that I know x is 2.5. So 2 times 2.5 minus 6. 2 times 2.5 is 5, and 5 minus 6 is negative 1. So that means that these two lines should cross at 2.5, negative 1. And if I have technology help me out, you'll see that they do indeed cross at 2.5, negative 1. So we did it right. So step 1, step 2, and then this was the step 3, substituting our value into either one of the original equations to solve for the other coordinate. So the cool thing is you're using algebra to actually find where two lines cross without even graphing it. That's kind of crazy, to find where two lines cross without even graphing them. Gonna have you try, and then that'll be it, except for one special kind of case one where we got multiple steps on the last one. But I'm going to have you try one just like the one that we just did. So on the whiteboard, I'd like you to try x equals y plus 3 and x plus 2y equals negative 6. Tell me if you can find where these two lines cross by graphing without even graphing them. Or sorry, if you can find where these two lines cross by using substitution without graphing them. So pause the video now, try to use substitution to find where these two lines cross. Use the example we just did as your template. So pause the video, come back after a few minutes, and we've had a chance to try. Okay, here's how it would work. I already have x solved for, so step 1's done. Now I'm going to do step 2. Take y plus 3, and I'm going to rewrite it where x is in the other equation. So now instead of writing x, I write y plus 3. I don't need to put parentheses around it because there's no number in front of x, so I'm not going to have to distribute anything. Plus 2y equals negative 6. 1y plus 2y here makes 3y, so I have 3y plus 3 equals negative 6. Subtract the 3, I would get negative 9, and then divide by 3, and I get negative 3. So those two lines are going to cross when y is negative 3. To then figure out what x is, I do step 3, which is take the y I got and put it in either equation. The top one's the easiest because x is already solved for, so x is equal to negative 3 plus 3. X has to equal 0. Those two lines should be crossing at 0, negative 3, and you'll see that they do indeed cross at 0, negative 3. That's what you should have got. Okay, now we need one to do one where we actually have to do step 1. So step 1 was to get one of the variables all by itself. You have 4 options. You could do the green x, green y, this orangish x, or the orange y. I think that either the green x or the orange x are the easiest because the green x you'd have to just simply add y. For the orange x you'd have to simply subtract 4y. If you're going to try to solve for y, you'd have 2 steps. Like in this green one, you'd have to subtract x and then divide everything by a negative 1. So now we're not going to do that. So if I solve this green equation, so x is all by itself, I get x is equal to 2 plus y. That is step 1. Step 2 is taking 2 plus y and then rewriting it when I write the second other equation. So in this other equation, instead of writing x, I'm going to write 2 plus y. Then plus 4y equals 17. 1y plus 4y is 5y, so I get 2 plus 5y equals 17. I subtract 2 from each side. I then get 5y equals 15. If I divide by 5, I get y is 3. So I know that those two lines are going to cross when the y coordinate is 3. Now I need to solve for the x coordinate. I technically have 3 options now. I could do the original green, the new green, or the original orangish one. So I'm going to do the new green one because x is already solved for. X is equal to 2 plus y. Let's actually do this here. So x is equal to 2 plus y, but we found that y was 3. So x equals 2 plus 3 means that those two lines should cross at 5, 3. And if I check, I will actually see that those two lines do indeed cross at 5, 3. There you go. So there's one where it has all 3 steps. Step 1 is actually more, let's do this. Step 1 is actually more going on right here. Step 1, getting x by itself. Step 2 is substitution. And then this is step 3. I'm going to have you try one where you have to get a variable all by itself. And that is as tough as it can get. So You have four options, either the top x or the top y, solve them for themselves, get it by itself, and then substitute into the bottom. You could do the bottom x or the bottom y, but that would have multiple steps. You'd end up with some decimals or fractions and probably want to avoid that. So use the one we just did as an example. That's as tough as it can get. Find where those two lines cross by substitution without even graphing them. So pause the video now. Try this one for yourself on the whiteboard. Okay, let's see how it went. For this first part, if you solve for x or y, it doesn't matter. You could subtract the x. You would then get y equals 4 minus x. And I'm going to take this then and substitute it right down here where I have y. So instead of writing y in the other equation, I'd have 7x plus 3 times 4 minus x equals negative 4. Distribute your 3 through. I get 7x plus 12 minus 3x equals negative 4. I've got variable number, variable number. I combine my variables because they're on the same side, so I get 4x plus 12 equals negative 4. Subtract the 12 and I get 4x equals negative 16. Divide by 4 and I get x equals negative 4. If x is negative 4, I can get y by putting negative 4 in for x up there, and I get 4 minus negative 4. And 4 minus negative 4 is going to give me 8. So I should find, as long as all things went right, those two lines cross at negative 4, 8, and they do. So there you go. That's how the last one should have gone. Thank you very much. That's solving systems by using substitution. Have a good day.